grade is problem solving using polynomial equations. So we've already solved using systems of equations. We've solved just simply using linear equations. Now we're going to look at using polynomial equations. We're going to take some real-life applications to see this. Now, we also have to make sense of our solutions. What we're going to notice here is this. When we've been solving these equations, we've been getting not just one solution, but sometimes two solutions, sometimes three solutions. And sometimes the solutions to the equations don't make sense in the word problem. So we have to reject some of our answers today. So for example, if I were to find a problem that said, determine the amount of time, or when in time, does this projectile land on the ground? If you get two answers, one of 10 seconds and one of -4 seconds, what can you say about that right away?
You can't use -4 seconds.
Yeah. It'd be like going back in time, right? -4 seconds there. It wouldn't make much sense. So we would reject that solution. So that's what that second bullet means. Make sense of solutions. Is that clear? So if you get a negative amount of money for something, either A, you did something wrong, or B, you have to reject that solution and only use the other one that you got. All right? All right, let's go. First example. A boat is attempting to fire a missile to the east at a civilization that is located on an island. Okay, the path of the projectile follows the following curve. F of x equals -6x squared plus 18x plus 24, where x is the horizontal location in miles, and f of x is the height of the missile in yards. Two different units. Notice that right away. Yards and miles. If the island is located 6 miles east of the boat, will the missile strike it? Will the missile strike it? So it's located 6 miles east of the boat. 6 miles east of the boat. What can we do for the problem like this?
Plug in 6 for x.
And look to see that you get?
I'm not sure.
Okay. You could do what you're saying, George. I didn't even think about that. That kind of does work, but what do you have to look for here?
I was going to say, you convert yards to miles.
Okay, we could do a conversion for sure. Good, good. You can definitely do that. But let's go back to what Georgia said still. She said you could just try and plug in 6 into f of x. If you plug in 6 into f of x, right? And let's say the answer is you get, plug in 6, say you get 20. Hypothetically speaking, it's not 20. Okay? Say you plug in a 6 and you get 6 comma 20. It means that at 6 miles, the missile is 20 yards above the ground. Right? So if I plug in 5 and I get 50, at 5 miles, it's 50 yards above the ground. So clearly it's descending, but if that were the scenario that I just mentioned, it wouldn't have striked it. But what do we want x to be, or what do we want the height to be for the missile to actually strike the island? 0. So we're looking for the what of the function? The zeros of the function. If one of the zeros of the function happens to be a 6, right? It happens to be a 6, or if you look at the graph and interpret it the correct way, then it will work. So here's what I would do for a problem like this. Let's take a look and find the zeros so we can see where the missile is starting from and where the missile is landing, and then find the distance between those points to see if it's 6 miles. Because if you just plug in 6 here, it's actually a little bit off, and I'll explain why. But the idea is right, okay? So let's find the zeros of the function. All right, let's go ahead and do it. So from yesterday's lesson, what do I do to find the zeros of the function? Step 1. Yeah, we set the height equal to 0. Again, we're setting the height of the function equal to 0 to find out when the function is on the ground level or striking the island. Now, how would you factor this? Oh, you definitely would. Very good, Ida, because most people might say, AC method. This is a messy problem. Think about AC method right now. 6 times 24. You have to figure out what multiplies to 144 and adds up to 18. That's a little bit messy, isn't it? So factor out a -6. It's your GCF. And why did I say -6? Just so you have a positive leading coefficient. What do I get when I factor out the -6? Tori May.
You get x squared minus 3x minus 4.
Very good. So we have x squared minus 3x minus 4. At this point in time, What can we do with this part? Summer? Into?
And the numbers are going to be 4 and 4. X minus 4x plus 1.
How do you know that's true?
Um,
It is true, but how do you know?
Because 4 times, negative 4 times 1 is negative 4, and 4 minus 4 is...
Yes, so the sum of these numbers is b, and the product of these numbers is c. Again, 1 times negative 4 is negative 4, 1 plus negative 4 is negative 3. So remember, the middle term represents the sum of these. The end term represents the product of these, always. That's how we come up with our factors. So what does this tell us about the graph now? Where are the zeros located? How do I solve this? What do I do to finish? Right? Now, is this first one going to do anything for me? Is that true? It's not a solution. Because we could really just divide by negative 6 before we did all this. What's 0 divided by negative 6? Still 0. So the negative 6 just drops off. Anytime you have a number that can be pulled out and you're finding the zeros, you can ignore that number. But if it's an x that you pulled out, you would have to set x equal to 0 and solve. Please don't forget, if you factor out an x, you do have to account for it. Georgia, what do you get for the roots then? Or the zeros?
X equals 4 and x equals 1.
Okay, and again, those values come about from setting this factor equal to 0 and solving. Setting this factor equal to 0 and solving. So let's quickly draw an xy axis. And at 4, let's put a dot. And at negative 1, I'll put a dot. Those are my roots. Those are my roots. Now, this is just something I happen to know, and I'll explain to you why it makes sense in a moment. Whenever you have a quadratic, and this is a quadratic if we go back up and look at the original, with a negative in the beginning, a negative leading coefficient, it opens down. When you have a quadratic with a positive leading coefficient, so imagine this were like positive 6, it would open up. Not something you need to know this moment. We'll learn about it this year. But the graph of this is a missile. So it wouldn't make sense if it went like this, right? It would go underground and then come back around. Doesn't make any sense at all. So we're clearly going to be opening in this direction. So let's draw the path. Here's the missile. It's fired. Comes back around. Halfway. Let's see. 1, 2, 1, 2. We'll go halfway as a peak. Right here we'll make the peak. And then come back down. And that's what the graph looks like. The important part for us is this red portion right here. Okay? This part from this dot to this dot. That's the missile's path. Now it says that it has been fired east. So we could say that this is the boat. And this is the island. But where is the island located, folks? How many miles east of the boat? How many? 6. So start at negative 1. And add 6. You get all the way to 5, don't you? So here's the island right here. So did the missile hit the island? No, it landed a mile short. Okay? So do you see now why it's important? Because this negative 1 distance had to be taken into account. If we had just plugged in x equals 6, we'd be looking for the, let's see, 1, 2, 3, 4, 5. We'd be looking for here. It wouldn't make much sense.
Would hit at 6 miles.
Exactly. Okay? So again, we draw the graph. We realize this is a gap of 5 miles. It's 1 mile short of the island. Now keep in mind, in real life, an island has a width. So the island really might be from like, here all the way to here, right? That might be the width of the island. So it might be even like only a half a mile short. Okay? So maybe the island is like this big. So in real life, we'd have to consider that. And there's a lot more involved. But the idea here is we're looking for the zeros of the function. Okay? Let's go to number 2. Can I get someone to read for me? Read. Tori May?
2 numbers differ by 5 and have a product of 84. Find the numbers using algebraic numbers.
What does it mean for 2 numbers to differ by 5?
The difference between the 5.
So give me an equation.
So x plus 5 equals 1.
So interesting. And I love the way people think differently. And I that makes sense. But what do you think I was thinking? No?
X plus y equals...
See, you're doing it the way you're making one of them 5 more than the other, which is right. But anybody want to guess what I was thinking?
Like x minus 5.
Oh, I wasn't even thinking that. I wasn't thinking that either.
X like minus y equals 5.
Yeah, I was thinking two numbers differ. That's what two numbers differ means. By 5. But doing it the way you wrote it is fine.
Okay.
But just
looking for that, but
translating English to math, this is what it would look like directly, okay? Two numbers differ, x minus y, by 5 equals 5. And their product is 84. Their product is 84. Trooper.
Like xy equals 84.
Good. xy equals 84. So we've got a difference and we've got a product. Now, this is what? What is this an example of? Be careful with your terminology.
no.
Starts with an S, you're right on that. A system of equations. A system of equations. Now, we cannot use elimination. Write this down in big letters. Because the second equation is not linear. These are multiplied by each other. So this is called a nonlinear equation. When they're not linear, you can't use elimination. You have to use substitution. Liam, can you tell me please, in the first equation, which one would you like to solve for? X or y?
X.
All right. So we'll add y to both sides and say that x equals 5 plus y. We'll take that and we'll plug it in here for x. Does everybody agree with me? Or solve for it in the first equation because it's a whole lot easier. Try and solve in the second equation, you get something over y or something over x. Then plugging that in is so messy. So let's plug in 5 plus y in for x, resulting in the following. So 5 plus y goes in for x, times the y equals 84. Okay? Do you see now that this is clearly going to be a polynomial, or at least a quadratic? Because what are we going to have to do with this y? Distribute. And then I'll move the 84 over by subtracting it, and I'll put it in standard form at the same time. So I'll switch the order of these two, so it's in standard form, then I'll subtract the 84. Okay? Does this make sense till this point? Because this lesson 4.8 is about what we just did. Everything else from this point on, you can do on your own. I mean, we'll do it, but you can do it already from what we learned. But you need to make sure this makes sense. So for this problem, we started with the fact that the difference between those numbers is 5. The product is 84. We solved for one in terms of the other, moved it into the equation, rewrote our product equation, then distributed, then moved it over to put it in standard quadratic form. At this point, what do we do? What do we do now? What do we do now? Austin. If we do that, though, it's going to get messy because we're going to have the y's here. What are the factors of 84, Austin? What can multiply to give us 84? And this is going to be a little bit confusing here. 7 and 12. You picked up on it right away. And 7 and 12, don't they give you 5? 7 and 12 can give you 5. So he picked the factors right away. So you have to list the factors of 84. So 12 and 7, and we'll make one of them negative, or negative 12 and 7. There's going to be 42 and 2. There will be 3 and 28. But 12 and 7 we'll stop with, because 12 and 7 definitely give me 5 in the middle. Which combination do I want to choose? Which combination do I want to choose, Worth?
Negative 7 and 12.
Why?
Because 12 minus 7 equals 5.
Yeah, we want this to be a positive in the middle. Everybody see that? So the bigger number needs to be positive. Again, 12 and negative 7 give us 5. 12 times negative 7 gives us negative 84. Georgia.
But then when you, after that, but then when you find solutions, you have negative 12.
Well, that's what we have to talk about. Yeah, so
That's, they don't differ by 5.
hold on. Remember, we have to go back and think about what our beginning was. These definitely don't differ by 5. You're absolutely right. In the beginning, we never made a let statement, right? Remember, we never made a let statement? All we did was solve for y. We have to still get x using one of our originals. Okay? So y could be either 7 or negative 12. So let's write this down. For y, it could be 7 or it could be negative 12. Again, based on our answers, for y, it could be 7 or negative 12. Now, if that's what y can be, we need to come up with an x value for each of those possibilities. So what do we do with these numbers, 7 and negative 12? Arthur? Which one, Arthur?
Just do the first form.
Yeah, but does it really matter, Arthur?
No, it doesn't.
It makes no difference, okay? To me, it might be easier the second one, because I know what I'm good with factors. So if I plug 7 in for y, x has to be 12. If I plug in negative 12 in for y, x has to be negative 7. This product gives me 84. This product gives me 84. The sum of these, they differ by 5. They differ by 5. Okay? Look at the numbers. Do the math in your head. What do 7 and 12 differ by? And their product is 84. But negative 7 and negative 12 also differ by 5.
Oh, so the answer, I thought we still had to keep...
There's two different answers. This is the first answer. Okay, we're trying to find two numbers. Try to find two numbers that differ by 5 and have a product of 84. There's two possible solutions. 7 and 12 and negative 7 and 12. Okay? If you have any problems like this, where they differ by a value and their product is another value, there will always be two sets of answers. Okay? There will always be two sets of answers. And they'll be opposites of one another. Georgia?
So is that it?
Yeah? That's it. We can't go any further. We have to say that there's two possible solutions. Okay? All right, next one. Reader, please. Reader, nice and loud. Worth.
Okay. The length of a rectangle is 1 meter?
Yep.
1 meter less than twice the width. If the area is 55 meters squared, find the perimeter.
All right. So give me a let statement based on the first sentence, please. Based on the first sentence, I want to hear a let statement from you. Let blank.
Well, let L equal length and W equal width.
Okay, now based on the first sentence, I'm sorry, I should have said give me an equation. Give me an equation based on the first sentence now, Francis.
So it's L equals 1 minus 2W.
And that's tough to see because if you read it the other way, right? 1 less means minus 1 at the end, okay? So 1 less than twice the width, well here's twice the width, 2W. 1 less than that is minus 1. If twice the width is 15, 1 less than that is 14. So put the minus 1 at the end. That's awesome, that's our first one. What's the second equation from the second sentence, Ida?
L times W equals 55.
Yep. And now take a look. It's the same kind of problem as the last one. We already solved for L, so we might as well just plug that right on in. Let's take this expression here and substitute that in for L. We get 2W minus 1, that quantity times W, equal 55. Okay, there's not even a need to draw a diagram here. You can, and you could put your let statements on your diagram. That's fine with me. And some students will do this. Ready? For the length, for the width, they'll put W. And for the length, they'll put 2W minus 1 and 2W minus 1. Okay, you can do that. That's fine, just to remind yourself. But that's what this equation says at the bottom. Width times length equals 55. How do we solve this? We should be doing these quick now, very quick. Arthur, give me first step. Distribute. 2W squared minus W equals 55. Second step, quickly. Liam. Yeah, bring the 55 over. Uh-oh. What do we got to use here? AC method. Okay, we got to use AC method here. Now, what's that? 11 and 10? Let's take a look.
How did you know
And
that?
5 is 11 and 5.
Okay. I know.
AC is 110. Whoops.
You divide 5 and you get 11 minus 10. That doesn't...
AC is negative 110.
I see that you get 10 and negative 10.
Makes more sense.
Because you multiply the 2 by 5.
All right, relax. So AC is negative 110. Two numbers that multiply to give you 110 are 10 and 11 right away. Okay, 10 and 11. And don't 10 and 11 differ by 1? So you can see this is a 1 here, right? So 10 and 11 should work if one of them is negative, one of them is positive, which we need them to be. So we'll use negative 11 and positive 10. Because again, the negative 11 is bigger than the positive 10. So when I add those numbers together, I'm going to get the negative 1 that I want in the middle. See again, these two give me the negative 1 from the middle. So now I break up the middle term into that. So minus 11w, which a lot of you are forgetting. The w needs to be there. You can't just put minus 11. It's not the same thing. Plus 10w minus 55 equals 0. So again, these come from right here. Okay? And this is messy. You know what it takes, honestly? More and more practice and knowing your factors. That's why when you were a kid, you studied those annoying multiplication tables. You see how useful they are now when you're doing this? Who wants to sit in their calculator and do 110 divided by 1, 110 divided by 2, 110 divided by 3, and go through all the possible factors? It's helpful to know the factors. For example, 5 times 22 is also giving you 110. So if this middle number had been different, it could have been 5 and 22. That's not one that you might think of right away, but that is another set of factors. Okay? All right, at this point we want to factor by using what method?
Grouping.
Grouping. What is the indicator to remind me to use grouping? What's the indicating factor? How do I remember to use grouping?
4 terms.
4 terms. Very good, Liam. 4 terms here. When you see the 4 terms, you want to think about grouping. All right, all we can take out is a W. That's it. There's not much more than a W that we can pull out. What can we take out of the right side? Georgia?
5.
Good. Now, those ladies who heard Georgia say 2W minus 11, W plus 5, now do you see where she got it? She was jumping right to the answer before. She wasn't trying to tell you guys what these factors were. That's why I said just relax for a moment, because you were both thinking of different things. So it does become W plus 5 and 2W minus 11. But some people were asking about AC, Georgia, and you were answering with the answer. That's why you were on different wavelengths. So remember, answer the question you're asking each other. Make sure you're on the same page. Now, I have 2 possible solutions because I have 2 factors. Please tell me right away, what restriction do I have to make automatically before I even get my answer? Can't be negative. How come, Ida? Can't have a negative width. Right? Is the rectangle negative 3 meters long? So right away we know that this first factor, giving us W equals negative 5, reject it. Okay? The second one is just going to be 11 over 2, which is 5.5 meters. That's the width. Thus the length is... We can plug it into either one here. We're going to get 55, so it should just be 10 to move the decimal over one spot. Okay, but it doesn't matter which equation you want to plug it into.
It says find the perimeter.
Oh, find the perimeter. Thank you, Arthur. So, Georgia, I should answer the question being asked now. I didn't find the perimeter there. I did what I just said to you a moment ago. Okay? So I found L and W, but as Arthur just said, it says find the perimeter. It doesn't say find L and W. So what would the perimeter be for this problem? How do you find perimeter?
2 would be 10, well, 11 plus 20.
Okay, so he's saying 2 by 5.5. Oops, let me switch them, because you said 11, right, first? Not that it matters, obviously.
32. Only 31.
What about units? Meters. By the way, meters is M, miles is MI. Let's take a look at the next example. Does that make sense, the idea of the problem? The math afterward is not that tough coming up to here. Then you have to go ahead and remember to plug back in to get the perimeter. But the idea is the same as the last one. We have a sum and then a product, or a difference and a product, and we use substitution method to solve. See substitution method over and over again in this concept. Can I get a reader, please? Nice and loud for us. Arthur, go ahead.
Product of 3 consecutive integers is 21 more than the cube of the small integer. The smallest integer, find the integers.
What are 3 consecutive integers? What do they look like? What do 3 consecutive integers look like?
X plus 1, x plus 2.
Perfect. So those are our let statements. Let x equal the first integer, or the smallest. This is the second integer, and this is the third integer. If they were consecutive odd integers, how would this change, Ida? Yeah, x plus 2, x plus 4. What if they were consecutive even integers? How would it change?
X plus 2, x plus 4.
Good. Same thing, right? Some of you make that mistake sometimes. If they're consecutive odd integers, they're still x plus 1, x plus 2, x plus 4. If they're consecutive even, it's still x plus 2, x plus 4. Don't let the word odd or even indicate what you're adding to it, as in adding like plus 1 or plus 3 instead of plus 2 or plus 4. Again, whenever they're consecutive, odd or even, it's x plus 2, x plus 4. Because you're differing by 2 every time you move between even integers. Or every time you move between odd integers, you're differing by 2. The product of 3 consecutive integers. Translate, please. The product of 3 consecutive integers.
X plus 1. Yeah, x plus 2.
Is, keep going, 21 more.
21 more than the cube of x.
Good, more than, say plus, right? But yeah. 21 more than the cube of x, the smallest integer. X is the smallest integer. 21 more than the cube of x. Now this is just a really messy problem. That's the only thing that makes it tough. Okay? The only thing that makes it tough is that it's messy. How would you approach? You cannot, please, you cannot solve this, even though it looks like it's factored. Because what's not over here? What do we need over here in order to solve this when it's factored? 0, by using the 0 product property. But if you don't have 0, you can't use the 0 product property. So we need to actually multiply this out and move over the like terms. Okay? What's the easy way to multiply the left-hand side? There's an easy way and there's a hard way.
I would FOIL it and multiply the entire
Yeah.
by x.
FOIL first, and then just increase every degree by 1 for x. So FOIL first. FOIL means first. Outer is going to give me 2x. Inner is going to give me 1x, giving me 3x in the middle. And then last is going to give me plus 2. Questions on that step? You see how I'm jumping that step and not showing all the steps of FOIL? Outer is this outer bracket. Inner is the inner bracket. 2x and 1x gives me 3x. Now distribute the x. And you're going to see some convenience here. Yeah, what happens, Arthur? What's it? Yeah, the x cubed on both sides is there. So if you subtract the x cubes from both sides of the equation, they both drop off. Leaving us with 3x squared plus 2x equals 21. What do I do with the 21? Move it over. Now here's the deal. Again, AC method works. But 21 is really only 7 and 3 or 21 and 1. And 3x squared can only be 3x and x. So if you want to go trial by error, or trial and error, not trial by error. If you want to go trial and error here, you can go ahead and do that. Okay, but I'll do AC method just to show it. AC is negative. Okay, B happens to be 2 in this problem. So what numbers multiply to negative 63 and add up to 2? Quick. 7 and 9. 9 times 7 is 63, and 9 and 7 differ by 2. Now, follow up. Which one's positive, which one's negative?
Negative 7. Negative 3. Wait. Negative 7, sorry. Yeah, negative 7 is 9.
And 9, good. Because we want it to be a positive 2, don't we?
Yeah.
So Francis, the 9 is bigger and the 7 is the smaller one. That's why you said that, right? Okay. I heard like 2 or 3 there. That's why. Ah, I got you. Okay. So let's break up the middle term now. 3x squared minus 7x plus 9x minus 21 equals 0. So again, these two terms here come from right here. And how do you check that you did it right? If you added these two terms, you get back to the 2x that was above it. That's how you can always check. Factor by grouping, Summer. What do we get in the first half?
Above x.
Good. Leaving behind?
3x minus 7.
Perfect. And on the right-hand side?
You can pull out 3.
Leaving behind?
3x minus 7.
Very good. And she noticed right away that once she had 3x minus 7, look for what gives you 3x minus 7. Well, taking out a 3 out of both of these gives you 3x minus 7. So our solution is... I always take out the one that's common first, but it's the same thing, right? And x plus 3, yeah? Now, what was the gist of this problem? Where did we start this? What are we finding? Not finding the cube of x.
Oh, the first.
Finding 3 consecutive integers. So can I have a decimal answer here? I cannot. So is the first one even possible? So don't even do it. Again, it's an integer you're looking for. When you break this up, this answer doesn't matter. 7/3 is not an integer, so reject it right away. That's the first integer, right? X. So here's one answer. What's the second integer? It's consecutive, so what's after negative 3? Negative.
2.
They're not odd. It's just consecutive integers. And then. Thank you. Okay? So please be careful. The common mistake I will see on a test is this. They'll put negative 3 as the first answer, then negative 4 and negative 5. Thinking like, oh, it's getting bigger. But that's getting bigger in the negative direction. We want to say, go back to the beginning and look at our let statement. It's whatever x is plus 1. Whatever this is plus another 1. So we're adding to the right. So the three numbers are negative 3, negative 2, and negative 1. And you can check this. Okay? I'm not going to check it for the sake of time. I want to get to the last problem now. Alright, before we get to the last problem, I have just a quick blurb about projectile motion. You don't have to memorize this. I will give you these equations on the test. You do not have to memorize them. Is that clear? What do you have to memorize for the test? Sum and difference of cubes, okay, and dots. But you do not have to memorize this. Now, the first one is when the height is measured h of t in meters, and the second one is when height is measured in feet. This number here, negative 4.9, is half of the gravitational pull on Earth. The gravitational pull on Earth is negative 9.81 meters per second. That happens to be half, and that comes from your equations in physics. This negative 16 is half of the acceleration in feet per second squared, which happens to be negative 32.2. So these are the accelerations, really, but that doesn't really matter right now. They're just constants for you guys, but so you know where they came from. In both cases, t is measured in seconds, and v0, this is called v0, v0, represents the initial velocity of the object. So, ready? Here's the object, and it's fired with an initial velocity of 30 meters per second. So it launches off, and then it takes a parabolic path, turns around, it comes back down. Hence the negative in the front. Remember earlier I talked about this negative, meaning that the parabola would open down. Again, the negative in the front would have a positive initial velocity. It gets launched off, and it comes back down. Okay? So that's what we're doing with these problems. Let's go to the example now. Keep this in the back of your mind, or even if you need to take a quick snapshot of the equations, because we're going to use them on the next slide. A signal flare is fired upward from ground level with an initial speed of 294 meters per second. A balloonist cruising at a height of 2450 sees it pass on the way up. So it's fired up, goes straight up. The balloonist is passing by, and it sees it pass on the way down at a height of 2450. How long will it be before the flare passes the balloonist again on the way down? On the way down. So, can we draw what's going on here? Can we draw this one? So, a signal flare. It's like you ever see somebody in a boat and they want to shoot a flare so a plane can see them? They launch the flare straight up. So, the signal flare gets launched straight up. Okay, it gets fired with an initial speed, V0, of 294 meters per second. So which equation am I going to use right away? Somebody tell me. Based on the units of the velocity there. Am I going to use the one with the negative 4.9 or the negative 16? Arthur? How come? It's in meters. So I can write this equation down already. All right? Now, it's fired upward from ground level, so we could say that this is the ground here. A balloonist is cruising. What does cruising mean? Just like floating along, right? Hanging out. Here's the balloonist.
Chilling.
And we could say that the person is hanging out right there, okay? They see the rocket or the flare, whatever it is, the object, it doesn't matter. They see it pass by on the way up, and it's 2450 in height. How long will it be before the flare passes the balloonist again on the way down? So we have this object, it gets launched, it comes up, passes 2450, turns around, comes back down. Why does it turn around? Why does it turn around? Logic. Why does it turn around? Chris? Gravity. Gravity slows it down till it has no velocity, and then it has negative velocity. So the flare keeps going, and then it comes back down. We want to find the time period that exists or that occurs between this gap of time. Is that clear what we're doing? Now, if I said to you, Worth, it takes 7 seconds to get to 2450, and then it takes a total of 14 seconds, or say 7 to get here, but it takes 11 to do a loop like this. What would the answer be then? If it took 7 to get here, but it took 11 to do a loop. If it takes 7 seconds to get to the 2450 mark, but then I told you it's fired again, and we notice that after 11 seconds it gets to the 2450 mark, but on the way down. What's the difference between those two numbers there? 4 seconds. So if it took 7 to get up here, but the total time to get around was 11, this difference would be 4, right? So why don't we set the height equal to 2450 and figure out what the time takes to get here. So set this height equal to 2450. Because that's what we're trying to find. We're trying to find the time when the height is 2450. The V0 is at the bottom, 294. Let's move the 2450 over. Okay, now, it looks like a really messy problem. But believe it or not, 4.9 goes into every one of these terms. You could factor out a negative 4.9 here. I'm going to show you guys tomorrow, in the beginning of the review, how to solve this equation on a calculator. Instead of doing it by hand, getting the factors and setting them equal to 0, you can solve this on a calculator. I'm going to show you how to do it tomorrow. But I'm telling you now that negative 4.9 factors out. So divide everything by negative 4.9. You're going to end up with t squared minus 60t plus 50. Okay? And that is quite convenient. This factors into t minus 10, t minus 50. Give me another 2 seconds, please. So we get an answer of 10 and 50. What's the difference between those numbers? 40 seconds. So here's what it means. After 10 seconds it gets to here, okay, and it stops, make believe, the problem's over. But if we did this again, after 50 seconds, it would do this full loop. That takes 50 seconds, that takes 10 seconds. So what's the time in between the loop? 40 seconds. Okay, again, it says how long will it take to pass it again. It passes it once, it loops around, it's 40 seconds duration for the next time. Homework tonight is from 4-8, a few problems, and then just some mixed review.